All right. Thanks for the introduction. This is joint work led by Stevens LeBlanc, who unfortunately couldn't make it. He is currently at EPFL, and this is work that we did with our colleagues at the Max Planck Institute. So the topic of this work is targeted attacks. Targeted attacks are, by definition, low volume. And specifically, we're interested in these socially engineered messages that target specific victims to install malware. Now, there's been a few studies on this. In particular, at Usenix Security, there were 3 studies. One focused on Tibet, one on the Middle East, and one on the Uyghur population that was actually conducted in part by Stevens. And in terms of the characteristics of these studies, they're really difficult to do. So if you look at the time to execute these studies, we're looking at upwards of 5 years of working with targeted vulnerable populations. And the only reason the Uyghur study was so short is because the data had already been collected by the time Stevens joined the project. And if you look at the number of samples you get, it's incredibly small. We're talking about less than 100 samples over all of these years. For the Middle East case, this study wasn't even necessarily focusing on targeted attacks, so we don't have a great estimate of how many samples they got. But the key takeaway from this slide is that measuring targeted attacks is a long and difficult process. You have to interact with individuals, and you have to wait a long time. As researchers, this is not something we like to do, either of these things. So what do you want to do if you don't want to talk to people and you don't want to wait? Well, one thing that we thought about is it's possible that antivirus aggregators, such as VirusTotal, could be something that we could use to help address this problem, to get better scale and not have to wait. So what is an AV aggregator? For those who aren't familiar, there's users all over the world who upload their files via a web interface. You can upload this to their system. What they have is access, today VirusTotal has access to over 70 AV software. They run your file against the AV software after you upload it, and then they give you a report of how many of them detected it as having malware, how many saw that they were benign, and this gives you an indication of whether the file in question might be something you want to get rid of real quick. So in terms of the stats, what do we get out of VirusTotal? There are several dimensions that are interesting here. First, in terms of coverage globally, there's a big bias towards the US, the blue part of that pie chart, but you see there's a ton of other countries that are represented all over the world. Now, you also get a huge number of uploads per week. We're talking about millions. And in terms of the file types, stuff that isn't terribly surprising, the most common cases are Windows DLL and exe files, sort of your run-of-the-mill, like, hey, you should be really careful about installing these things. But if you look at the tail of files that are uploaded, what you'll see is a lot of examples of documents. So things like PDFs and Microsoft Office documents that, where they have readers that are known to have vulnerabilities that can be exploited. So that's something we want to focus on. So a key question that we ask in this work is, can we use VirusTotal as a vantage point to measure targeted attacks? So what we did is we worked with VirusTotal to get access to their API. We accessed all of the files that had been uploaded. Then we brought those over, actually to MPI, but here I'm showing EPFL. And then we extracted the interesting examples to do analysis on. So I'll go through the methodology of how we did that. But before I do that, there's several research questions that we try to answer in this paper. And I won't have time to cover all of them. So I'm going to focus on the first few. So the first is, why do we even think that VirusTotal might be helpful? So a good question is, are targeted groups uploading exploit documents to VirusTotal? We'll show the answer is yes. Given that VirusTotal has an enormous amount of data, we're talking about several terabytes, the question is, can we scale our analysis to this large number of samples to actually extract these needles in the haystack of these targeted attacks from a large set of other documents? Once we've done this, we want to understand how these targeted attacks compare with each other across different groups. And last, what we show in the paper is how we can use VirusTotal data to infer how different actors use the system and how attacks take place, from attackers uploading documents to fuzz against VirusTotal to victims then uploading and eventually researchers. So first I'll cover the methodology, then how we analyzed exploit documents, and I'll conclude with a little bit of future work. So before I go into the methodology, I want to explain exactly what we're talking about here. We're not talking about macros, which is a very common thing that lots of researchers have looked into. When we say an exploit document, what we're talking about is an exploit that's paired with a decoy document, which is also then paired with malware. So this is often delivered as an email. It's socially engineered so that it looks like a legitimate document that a user should click on. Once they click on it, the exploit is triggered in the reader, which causes both the decoy and the malware to be dropped to persistent storage, at which point now the victim sees a legitimate document, is unaware that in parallel they've actually been infected. At this point, they're owned. So now I'm going to talk about the steps that we use to take our initial data set of files and eventually come up with a set that we use for analysis as targeted attacks. So the first step is acquisition, and we use two data sets here. One is the VirusTotal data, and we find all cases where VirusTotal had at least one AV that detected a document as having malware associated with it. That gives us about 260,000 samples. And because we had done a previous study with the Uyghur population, we also included those as well, and with that we have 143 documents. So that's our initial data set. The next step is to detect whether these documents are actually triggering exploits. Just because they've been flagged, of course, doesn't necessarily mean that they're working malware. So to do this, we need to run these documents in a wide variety of environments on a VM that's going to be vulnerable. So the way that we do this is we use Microsoft Office, and we use lots of versions and subversions of them, and we do the same with Acrobat. So essentially, we have a ton of different VMs where we're constantly automating the opening of these documents and seeing if they trigger any exploits, because the different versions of these different apps are going to have potentially different vulnerabilities. And we run all of this using Emmet, which is a tool that allows us to reliably identify when documents are triggering exploits in these readers. So from that 260,000 documents, when we run it in this environment, we find the vast majority of them aren't actually triggering exploits, and we're left with about 40,000 total documents that are doing something. We don't know at this point what exactly they're doing, but we know that they've run inside a Windows environment and that it seems like they've triggered an exploit. Now, a question you may ask is, why the heck do we have to use so many different VMs, so many different versions? Did this all matter? Was it worth it? And so one thing that we asked is, how many versions of readers do we have to test before a piece of malware is identified? Or another way to look at this is, in this graph, which is a CDF, is what is the number of affected versions that each malware can exploit? And what you'll see here is that the vast majority of these cases aren't successfully able to exploit every single version of the readers that we tested, which means that if you want broad spectrum coverage to actually be able to tell whether something is an exploit document, you have to run it against a bunch of different versions, or you're not guaranteed to actually find them all. Okay, so now we've detected something that's suspicious. Our next step is to extract what these exploits are doing. So in the extraction phase, we use the same set of environments, and this time we use a custom driver that we built that allows us to identify all of the operations that they're doing, including writing to disk and using the network. So as a result of doing this, what we find is that a large number of these are trying to do things like download a file that is no longer available, and so we rule those out as well. And in the final step, we have about 4,000 samples that are left for analysis. Now, in this last step, what we do is we extract what are the decoys, so what are the documents that are shown to users, to the victims, and also the malware. So what we want to do is, first of all, take just, at this point now, we're just focusing on VirusTotal, and we actually use translators to look at all of the documents. In this case, what we found is there were about 2,500 decipherable documents where we had translators for each language in which they were written code them so that we could classify them in a variety of ways. In addition to the decoys, there's various malware families that were dropped. So we ran these through commercial malware sandboxes. One is FireEye, another one the vendor preferred not to be named. All told, at the end, now we have labeled targeted attacks in terms of what were the decoys and what was the malware that was dropped. So now I'll give you some summary results of the analysis we did on these documents. One of the first questions that we wanted to answer is, are we actually seeing targeted attacks in VirusTotal? And the short answer is yes. So in this table, each row contains the affected group, the number of examples that we found, and the fraction of the total. So we found over 1,400 cases that were clearly targeted attacks. You'll see, for example, the Uyghurs and the Tibetan population were uploading targeted exploits. In fact, you'll see both of these are over 100 documents, which already yields larger numbers than we're seeing in previous studies. But of course, it's not just the Uyghurs and the Tibetans. We see both large countries and small affected by very targeted attacks. So the takeaway is that VirusTotal, in fact, is giving us pretty nice visibility into attacks targeting a large number of groups. Now, another question we ask is, how targeted are the attacks? And one way to look at that is, are they using broad spectrum attacks that use basically one language and just hope that some of the victims will open them? Or are they actually trying to send documents that are targeted specifically to the victim's native language? So what we're showing in this graph, each bar represents the fraction of decoy seen in each region, and then whether the language was English, and it was the official language, English which was not the official language, or if it was using another language that was the official language. So the first takeaway is, in India, the Philippines, and the US, large fraction of English language documents, which are official languages in those countries. We do see cases, Myanmar and Tibet, where English is predominantly used and it's not the native language. But when we look at the other cases, we see a large fraction of those regions are affected by documents that are tailored to the official language of that region. So the bottom line is that decoys often, not always, but they are often using the official language of the groups they target. So there's definitely evidence of strong targeting. Another thing we wanted to visualize is whether the malware itself was being targeted only to specific populations. So what we did to help visualize this is we clustered using nodes and edges. Each node represents a malware family and a region pair. So, for example, what you see in the top right is lurid, and then that's specifically to when we've seen lurid in Vietnam. The larger the size of the node, the more examples we saw. Each color represents a different country. So the colored lines are connecting different malware that are deployed in the same country. And the gray lines indicate links between malware families that are the same and deployed in different countries. All right, so that's a lot to digest, so let me try to help you understand what's going on here. First, if you just look at these clusters of the same color, this is telling you what malware is affecting each region. And what you see very largely in this case, for example, is that lurid, for the most part, exclusively affects victims in Vietnam. We do see some gray edges that I've just highlighted, so it is affecting 2 other countries, but that's a very small minority of the total set of examples. Now, there is an example, PlugX specifically, we see very broadly deployed, so this seems to be not as much of a targeted attack. But if you look at most cases for most countries, there's very tight clusters where a small number of families affect one country and not very much in the others. Now, another way to look at this is even if it's affecting more than one country, which in most cases we see malware is affecting only a handful, if it's affecting more than one country, is it affecting countries in the same region? So we came up with what we thought were somewhat natural groupings based on what we observed. So Chinese influence for Tibetan, Uyghur, and Taiwanese populations, Asia Pacific, those that are not in the G20 and those that are, and then Russia and the US as well. And what we found when we grouped the fraction of malware that affects multiple countries, so for each malware family, we find mainly one region is being affected. So for example, in the Chinese influence region, we see a handful of pieces of malware that predominantly affect that same region. There are cases, for example, like PlugX that I mentioned before, that don't really target any one region predominantly. And then we see, for example, Mirage, Lurid, and Page affect the Asia-Pacific region. So even when we find malware in multiple countries, they still tend to target a confined region. All right. So I'm going to wrap up with some future work and then conclude. We've done this analysis in a post hoc way instead of being able to monitor things live. So something that we'd like to investigate in the future is understanding how malware operators are behaving, how they manage their networks, how they try to evade AV aggregators and other mitigation techniques, how they're adapting their attack vectors, and actually deploy the same approach that we used to detect these targeted attacks on premises or use online services so that we can monitor these live as attacks are deployed. In terms of take-home messages, what we presented is a complementary methodology to the very good work of working directly with individuals in targeted groups and doing these long-term studies. It allowed us to measure targeted attacks at a greater scale. We found that at-risk groups are uploading documents to VirusTotal. They tend to be targeted with tailored decoys and malware families. And we're using our results to provide impact to the community. So both in terms of having deployed the service to an email provider with 100,000 users, and by making our data set available. So as far as I understand, because Stevens recently moved to EPFL, he's still in the process of setting up the service. But within a small number of weeks, you should be able to upload documents yourself to the service and get the same results. So at this point, I will wrap up. Thank you for your attention, and I'll take any questions, including the ones that I've kindly suggested right here. Thank you.
Hi, Roland Yap. Just wondering, since you are using an AV to detect it, does that mean that target attack is not particularly targeted? Because it's already found by AV, right?
Right. So I guess one way to look at one way to rephrase your question is
it's not unique, right?
Yeah. So these aren't 0 days because they've already been we have signatures that we could use.